Let us solve this Irodov problem 1.65. A plank of mass m1 with a bar of mass m2 placed on it. What is the question? There is a plank of mass m1 and there is a block of mass m2. m2 is placed on m1. It lies on a smooth horizontal plane. The plank is on a smooth horizontal plane. It means that there is no friction between plank and ground. A horizontal force growing with time t as F equal to At is applied to the bar. A force F equal to At, force is variable and applied on M2, not on M1. It is applied on M2 and the force is horizontal. It means the direction of force is constant but its magnitude increases with time. Find how the accelerations of the plank W1. Acceleration of plank is W1 and that of bar W2. Acceleration of block is W2 depend on time t. So we have to find the acceleration of M1 as a function of time, acceleration of M2 as a function of time. If the coefficient of friction between the plank and the bar is equal to k, there is a coefficient of friction between M1 and M2 and it is k. In next part, it is asked that draw the approximate plots of these dependencies. So we have to draw the graph of W1 and W2 with respect to time. So how to solve this question? To solve this question, we have to first deal with various things. First is, initially this block and this plank is at rest and t equal to 0. Initially there is no force. So M2 and M2 both are at rest. Now when force applied on this block, this block M2 try to move in plus x direction. So there will be a possible relative motion between M1 and M2 and M2 try to move in plus x direction. So first point is M2 tries to move in plus x direction. It means that friction force on M2 in minus x direction. Okay, this is true. When friction force on M2 is in minus x direction, friction force on M1 in plus x direction. Okay, this is true. Now, when there is no relative motion between M1 and M2, when no relative motion between M1 and M2, the magnitude of friction force between M1 and M2 should be less than or equal to maximum friction force. Next point is, when there is relative motion between M1 and M2, the friction force between the blocks should be equal to maximum friction force. So these are the common points which we have to keep in mind, and this surface is smooth, so we don't worry about the friction force. There is no friction force between plank and ground. So there are cases and we have to deal with all cases. First, about this contact surface. So normal at this contact surface is k into m2 into g, and this normal should be equal to m2 into g, and this normal has nothing to do with m1. This normal depends only on the mass m2. Next, the maximum possible friction force, its equation is k into n, and which is equal to km2 into g. This is the maximum friction force. So I write it. First point is maximum friction force should be equal to k into m2 into g. Okay. Now, there are two cases when both blocks move together and when acceleration of both blocks are different. That is, there is no relative motion between the blocks and there is a relative motion between the blocks. The first case is no relative motion between m1 and m2. In this case, I can assume that this whole as a system and the force acting on system is AT and there is no back force, so only this force is responsible for acceleration of both m1 and m2, and there is no relative motion between m1 and m2. In this case, acceleration w1 and w2 are equal, and this acceleration must be equal to force divided by mass, and force is AT and mass is m1 plus m2. So this is the situation. Now we have to verify up to what time both blocks move together. For that, we have to draw the free body diagram. Let me draw the free body diagram of M1. You can draw the free body diagram of anyone. So on plank M1, friction force will act in this direction. So this is the friction force, and this plank have acceleration W1. So from Newton's law, this friction force must be equal to mass into acceleration. And we know that there is no relative motion, so this friction force must be less than the maximum friction force. So F must be less than or equal to km2 into g. So m1 into w1 must be less than or equal to km2 g. What is the value of w1? So m1 into w1 is 80 divided by m1 plus m2 should be less than or equal to km2 g. So the time t must be less than or equal to k by a into m2 by m1 into m1 plus m2 into g. So I have got the time up to which both blocks move together with common acceleration. Let me write this time as t is less than and equal to k by a. Okay, k by a. Next, m2 by m1, m2 by m1. Next, m1 plus m2, m1 plus m2 into g. Okay, so in the first case, I have got the relation between acceleration and the time up to which this equation is valid. Now, in second case, both blocks have different acceleration, so the friction force acting between these two blocks is maximum friction force. So case 2 is relative motion between m1 and m2. So what will happen? The acceleration w1 and w2 are different. So we have to draw the different free body diagram of both m1 and m2. So for block m1, force is this in plus x direction 80, and friction force is in minus x direction, and it is maximum friction force, that is k m2g. So it is k m2 into g, and it is moving with acceleration w1. So what is the acceleration w1? It should be equal to force. What is the force? 80 minus km2g. km2g force and divided by mass. The mass is m1. So this is the equation for w1. For w2, we have to draw the FVD of m1. On m1, there is only one force in horizontal direction, that is friction force, and value of friction force is km2g. So it is km2g, and it is accelerating in plus x direction with acceleration w2. So what is w2? W2 is force divided by mass. What is the force? km2g. km2, okay, something is wrong. The mass of this is m2. So this is m2, not m1, and this is m1. Okay. So this is equal to k m2 into g divided by m1. So I have got all the equation. So let me write this equation separately, and then we have to plot and analyze these equations. So what is this? w1? w1 is a by m2 into time t minus kg. Okay. A by m2 into t minus m2 cancel out kg. So this is w1. What is w2? w2 is k into m2 by m1 into g. K into m2 by m1 into g. Okay, these are the two equations. Now look at this equation. This acceleration does not depend on the value of k. So this acceleration is independent of k but depends on time t. The graph of acceleration versus time will look like this. Up to this time, let me call it as t naught. So up to time t naught, acceleration of both blocks are equal, and this is the graph. W1 equal to W2. At this point, what is the acceleration? At this point, let me put t as this number. So when I put t as this number, this m1 and m1 plus m2 cancel out with this number, and a will cancel out with this number. So this part is cancel out, and we got only k into m2 by m1 into g. So the acceleration here is k into m2 by m1, k into m2 by m1 into g. This is the value. Okay. After that, after this time, see this equation. This equation is independent of time. The acceleration w2 does not vary with time. This is obvious because when friction force reaches its maximum value, the only force responsible for acceleration of W1 is friction force and its value becomes constant. So acceleration W1 becomes constant. So after this time, acceleration W2, acceleration W1. Oh, I wrote something wrong. Acceleration of this is W2. So this is W2 and this is W1. Okay. Now this acceleration W1 is this. The acceleration W2 varies with time. So acceleration W2 is dependent of time, but we have to look into this. Is the same line will continue, or the slope of this line decreases with time, or the slope of this line increases with time? So we have to decide which line is the best to represent. For that, I look at this is the part of slope and this value is a by m2. The slope after time t0 is a by m2 and the slope before time is a before time t0 is m1 plus m2. So this slope is less and this slope is high. It means that slope of W acceleration will increase. So this is the line after time t0. This is the line. The slope of this yellow line must be greater than this line. So this is the acceleration of W2. So this is the plot. And this is my final answer.